Hello friends, Mr. Burrell here. We are in our last trigonometry unit. We've kind of gone over two other trigonometry units, some introduction to trigonometry, some review. We've talked about graphing, trigonometric functions. We've talked about the unit circle. We've talked about all these different types of things. And now this is the last unit where we're going to talk about trigonometry. Kind of everything else about trigonometry that you might need to know that we haven't covered so far. So in this unit, we're going to cover talking about finding the area of triangles, all sorts of triangles, not just right triangles or not just triangles where we know the height. We're going to talk about something we call the law of sines, and we're going to talk about something we call the law of cosines. So that is this unit that we're going to start discussing. So to start, we're going to go ahead and start by talking about the area of oblique triangles. This is unit 13.3, but we're going to start with it. We'll talk about what an oblique triangle is if you're not familiar with that term, but we're going to find the area of triangles. Hopefully this isn't terribly new information, but we're going to talk about what makes this different. So by the end of this lesson, by the end of this video, this is what I hope you're able to do. I hope you're able to find the area of oblique triangles. When I say oblique, I just mean a triangle that's not a right triangle. Any type of triangle, I want to be able to find the area of it. So, to start this, we're going to find the area of this triangle right here. So just as a reminder, remember that the formula for the area of a triangle that we know is area is equal to 1/2 the base times the height. That's a formula for the area of a triangle. 1/2 times the base times the height. Okay, well, let's look at this triangle. Well, here's the base of this triangle. I can call this the base of this triangle. Oh, well, shoot, but I don't know the height of the triangle. I know this, like, slanted side, but I don't know the height. The height would be, like, what, right here? The height would be right here. Well, with what I know, I would need to find out what the height of this triangle is in order to be able to find the area. Well, conveniently, when I draw this, this line down, it's perpendicular to this bottom side, so I know that this is a 90-degree angle. And look at that! Right here, let me draw this right here. Right here, that's not the perfect drawing, but I have a right triangle, kind of a little mini right triangle inside of my original triangle. And with this right triangle, I know this angle, and kind of racking my brain for my right triangle trigonometry knowledge, this is an adjacent side, an opposite side, and a hypotenuse side. So if I want to know the height of this triangle, this opposite side of my mini right triangle, I can use right triangle trigonometry in order to do that. Let me remind myself real quickly of SOHCAHTOA. So if I'm looking for this opposite side and I know the hypotenuse, I'm going to use sine. So sine of 80 degrees is equal to this opposite side, call it x, divided by 5. Okay, well, sine of 80 degrees is 0.9848. So 0.9848 is equal to x over 5. If I multiply it by 5 on both sides, I get x equals, let me multiply by 5 in my calculator here, I get x equals 4.92. Okay, cool. So this height right here is 4.92. So the area of this triangle is 1/2 times the base, which is 12, times the height, which is 4.92. Well, 1/2 times 12 times 4.92 is about 29.52. And this would be inches squared, since I'm talking about inches. That would be the area of this triangle, using what I know about finding the area of a triangle being 1/2 times the base times the height. Okay, so I'm going to rewrite this expression real quick. So I'm going to label these different sides. I'm going to label this as angle A, this as side B, and this as side C. So ignore all this for a minute. I can come back to that in a minute. So this is angle A, this is side B, this is side C, which would make this angle C and this, or sorry, this angle B and this angle C, this side A. Well, go ahead and take a look at this. I'm going to go ahead and rewrite this expression, this area expression that I just discussed, but I'm going to be using the instead of the side lengths, I'm going to be using just the labels that I had for any generic sides of a triangle. So the area of this triangle will be 1/2 times the base, which I'm just going to call C, 1/2 times the base, which is C, times the height. Well, how did I find the height? What was x equal to? Well, x was equal to this side. Let me clear this up here. X was equal to 5 times by 0.9848, or equal to this side B multiplied by the sine of 80, or the sine of this angle A. It was this side B multiplied by the sine of this angle A. So instead of writing 4.92, which was the height, I can write the height as B times the sine of angle A. 1/2 times C times B times the sine of angle A. So this was the base of my formula, and this right here was the height of my formula. And this is going to lead us to discover a formula for finding the area of any non-right triangle where we know a side, another side, and the included angle. So the area of any triangle is 1/2, the product, or multiplying, the lengths of two of the sides times by the sine of their included angle. So this right here was the formula that I just did on the previous page. We had sine of angle A, we had side B, and side C. That was the base. So area is equal to 1/2 times B times C times sine of A. And it doesn't matter what the side lengths are. That is why I have these other two area formulas here. But the area of any triangle, if I know a side, an included angle, and another side, is 1/2 times by each of the sides multiplied by the sine of the included angle. That's how I find the area of any triangle given two sides and included angle. So let's try this out. These are examples in your guided notes. This says a triangle has sides of 12 inches and 15 inches. The measure of the angle between them is 24 degrees. What is the area of the triangle? So let's say this side is 12 inches. This side is 15 inches, a little bit longer. This angle right here is 24 degrees. So what is the area? Well, I could go back and say, okay, well, I'm going to need to find the height. I'm going to need to use trigonometry to find the height. But what we did before using trigonometry to find the height, we discovered this formula that will work every single time for finding the area of these kinds of triangles. So the area of this triangle is 1/2 times the product of the two sides, so times 12 times 15, times by the sine of the included angle, or sine of 24. That's it. I can plug that straight into my calculator. 0.5 times 12 times 15 times the sine of 24 is 36.6 inches squared. So that is the area of this triangle, 36.6 inches squared. Let's try another one. This is number 2 on your guided notes. It says find the area of each triangle to the nearest hundredth. So I have a side, another side, and an included angle. So since I have this side angle side knowledge, I can use this formula. The area is equal to 1/2 times the product of those two sides, 6.8 times 15, times by the sine of the included angle, sine of 50 degrees. So 0.5 times 6.8 times 15 times the sine of 50 is 39.07 centimeters squared. 39.07 centimeters squared is the area of that triangle. Okay, now let's do a couple of these types of problems from your homework. We're not done with the lesson video yet. There's another area formula we're going to discuss, but first we're going to find the area of some of these triangles using that same method. So I know a side, an included angle, and another side, so I'm going to use the area formula as follows. Area is equal to 1/2 times the product of those two sides multiplied by the sine of the included angle, sine of 77. So 0.5 times 4 times 6 times the sine of 77 is 11.69 yards squared. So it's given to me in yards. Area is a squared unit, so the area of that triangle is 11.69 yards squared. That was question number 3 on your homework. Question number 9, I have these two sides and an included angle, so I can use this sine area formula, which is 1/2 times the product of those two sides, 5 times 14, times by the sine of 101 degrees. So 0.5 times 5 times 14 times the sine of 101 is 34.36 inches squared. That's the area of that triangle. So in case you were curious or wondering, some of you are like, well, weren't we supposed to put the 14 first and the 5 second because this would be the base of the triangle? It doesn't matter, because when we're multiplying, remember, multiplication in math is something what we like to call commutative, meaning that 5 times 14 times the sine of 101 is the same as the sine of 101 times 14 times 5, or 14 times 5 times the sine of 101. It doesn't matter which order you multiply those in, you're all going to get the same result. Okay, so that's that first area formula that we're going to discuss. The second formula looks like this. So the caption here, you can also find the area of an oblique triangle if you only know all 3 side lengths. So if I have a side situation, if I know all 3 of the sides, I can use what we call Heron's formula in order to find the area. And on the last area formula, I kind of derived it for you. I showed you where it comes from. This area formula, it's a lot more difficult and time-consuming to show you where this comes from. I would recommend looking up on the internet Heron's formula, where it comes from, or if you're curious, let me know and I can direct you to a video where you can see where it comes from. But for the sake of this lesson, I'm just going to give this formula to you. So the area of a triangle where I know all 3 side lengths is the square root of s times s minus a times s minus b times s minus c. A, b, and c are the 3 side lengths, and s is this, 1/2 of a plus b plus c. So 1/2 of the perimeter of that triangle, or 1/2 of the sum of the sides of that triangle. That is Heron's formula for area. A little bit crazy, a little bit more going on here. Really cool where this formula comes from. Again, if you want to look it up, you can, but don't stress about it. You don't have to memorize this formula. I'm going to give you this formula and the other one that you can use. You can use this on your quizzes, whatever you need to. Write them down, use the guided notes, whatever you need to. Okay, let's practice this. So it says, find the area of each triangle to the nearest hundredth. So remember that the area, using Heron's formula, if I know all 3 sides, is s, the square root of s, times s minus a, times s minus b, times s minus c, where s is equal to 1/2 of the perimeter of the triangle, or a plus b plus c. Well, first, let's find what s is. S in this triangle here is going to be 1/2 times 4 plus 4 plus 5, because those are the 3 sides of the triangle, 4, 4, and 5. So that's equal to 1/2 times 4 plus 4 is 8 plus 5 is 13. So 1/2 of 13 is 6.5. So then putting that into my big area formula, I get the square root of 6.5 times 6.5 minus 4 times 6.5 minus 4 times 6.5 minus 5. That's my area formula. So you can plug that straight into your calculator. I'm going to take the square root of 6.5, parentheses, 6.5 minus 4, close parentheses, open parentheses, 6.5 minus 4, close parentheses, open parentheses, 6.5 minus 5, close parentheses, get out of that square root, whoo-wee, and I get 7.81 yards squared. 7.81 square yards. It would take 7.8 squares with a side of 1 yard to fill in this triangle. It's not a perfect representation of what that would look like, but whatever. Okay, so that's Heron's formula for finding the area. You can find the area of any triangle given all 3 sides using this formula. let's try this one. So again, first I need to find S, which is 1/2 of the sum of all the sides. So 11 plus 8.1 plus 16. Well, that's 1/2 of 11 plus 8.1 plus 16. 1/2 of 35.1, which is 17.55. So the area of this triangle is going to be 17.55 times 17.55 minus 11 times 17.55 minus 8.1 times 17.55 minus 16. Woo! Jeez. And again, you can type that all straight into your calculator, making sure that you type in the square root and type in all the parentheses as is. So I'll type in 17.55 parentheses 17.55 minus 11 parentheses 17.55 minus 8.1 times parentheses 17.55 minus 16. And I will get the area to be 41.03 centimeters squared. 41.03 centimeters squared. So it'll take about 41 square centimeters to cover this little triangle here. Okay, let's do a couple of examples from your homework. Again, the other two homework examples I gave you were when I had a side, an angle, and a side given to me. These two examples are going to be where I'm giving you all three sides, so we'll use Heron's formula. So first in Heron's formula, we're going to find S, which is 1/2 times the sum of all the sides. So 1/2 times 16 plus 13 plus 8, which is equal to 1/2 times, let's see, 16 plus 13 plus 8 is 37. Half of 37 is 18.5. So the area is going to be 18.5 times 18.5 minus 16 times 18.5 minus 13 times 18.5 minus 8. Let's go ahead and type this in your calculator with me. Make sure I'm not crazy. 18.5 parentheses 18.5 minus 16 parentheses 18.5 minus 13 parentheses 18.5 minus 8. And I get 51.68 miles squared. So I'm working in miles here. So using Heron's formula for the area when I'm given all three sides, I found that the area of this triangle is 51.68 miles squared. That was question number 13 on your homework. Now let's do number 19. So I have, again, I'm given all three sides, so I'm going to use Heron's formula. First, I'm going to find S, which is 1/2 times the sum of all the sides, or 1/2 of the perimeter. 1/2 times 16 plus 10.8 plus 11, which is 1/2 of 16 plus 10.8 plus 11 is 37.8. And half of 37.8 is 18.9. So then plugging that into Heron's formula, I get area is the square root of 18.9 times 18.9 minus 16 times 18.9 minus 10.8 times 18.9 minus 11. Plugging that all into my calculator, 18.9 parentheses 18.9 minus 16, 18.9 minus 10.8, 18.9 minus 11, I get 59.22 centimeters squared. As the area of that triangle, I got 59.22 centimeters squared. And I'm really hopeful that on all of those problems, I didn't make a calculator mistake. If I did, I apologize. But those are the two methods for finding the area of an oblique or non-right triangle that we're going to discuss. So again, in the past, you've talked about being able to find the area of a triangle if you're given the base and the height. And now we have the tools in our math trigonometry tool belt to find the area of any oblique, any non-right triangle regardless, as long as I either know 3 of the sides or 2 of the sides and an included angle. So that's the end of this video. That's the end of this lesson. I hope that now you're able to find the area of oblique or non-right triangles. The reason that this is in the trigonometry section is because of the use of sine in the one formula, and because of the trigonometry associated with discovering Heron's formula. In the next videos, we're going to talk about the law of sines and the law of cosines, so get excited for that. I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever, and I hope that you enjoyed that as much as I did.